Hello students, my this lecture is based on the topic electric potential energy. Students, electric potential energy. Let us suppose that two charges are placed at large distance and we bring these two charges close to each other to form a system. In this process of bringing the charges, we will have to do some work, and this work is stored in the form of energy, and this is known as electric potential energy. And therefore the definition of electric potential energy is the energy of a system of point charges may be defined as the amount of work done in assembling the charges at their location by bringing them in from infinity. Suppose charge Q1 is here, Q2 is here at infinite distance, and we want to bring these two charges from that point to this one and this charge from this point to this one. Then we will have to do some work, and this work will be stored as energy. Here, I am considering that the charge Q1 is situated at point P1, and therefore no work is done in bringing this charge from infinity, and therefore written here W1 is equal to 0. That is, the work done in bringing charge Q1 from infinity to point P1 will be 0 because of charge Q1 is already situated at point P1. Yes. Now this charge will produce potential field. This charge will produce field, and hence potential at point P2 will be what? We know that potential due to this charge Q1 at point P2 will be V1 is equal to 1 upon 4 pi epsilon naught Q1 upon R12. Okay, students, now we are bringing this charge Q2 from infinity to point P2, and therefore work done will be what? W is equal to QV, and therefore W2, because of we are bringing charge Q2 from infinity to point, so W2 is equal to V1 into Q2, the charge Q2, and V1 potential due to this charge, and this will be 1 upon 4 pi epsilon naught Q1 Q2 by R12. Yes students, so what will be total work done? Total work done will be the sum of W1 and W2, and which will be the energy, and therefore U is equal to W1 plus W2. W1 is 0 and W is this, therefore the electric potential energy of a system of two charges Q1 Q2 placed at distance R12 will be U is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R12. Yes students, this is the expression for the energy of the two charges. If there are number of charges, a system made by the number of charges, for example, here I am considering the system made with three charges Q1, Q2, Q3, then what will be the potential energy of the system? Giving directly formula, the energy of Q1, Q2, energy of Q2, Q3, energy of Q3, Q4, and this triangular system is made with three system Q1, Q2, Q2, Q3, Q3, Q1, and therefore potential energy U is equal to 1 upon 4 pi epsilon naught Q1, Q2 upon R12, this, then 1 upon 4 pi epsilon naught Q2, Q3 upon R23, this, and 1 upon 4 pi epsilon naught Q3 Q1 upon R13, this, and this is the total energy of the system. Similarly, we can find electric potential energy of system made with n charges. Students, here it is important that the take charge with proper sign. If charge is given negative, suppose that Q3 is negative, minus charge, then here it will be negative and here it will be negative. That is, in the case of electric potential energy, charges will be considered with proper sign. Students, the next topic is potential energy of a dipole. That was, in previous case, it was the energy of the system of charges. Now it is potential energy of a dipole in uniform electric field. Students, you know that the dipole is made with the help of two equal and opposite charges placed at short distance having dipole moment P with value 2qa. Yes? These parallel lines are showing the direction of electric field. Minus q plus q. This is a dipole of length 2a and the direction of dipole moment from minus charge to plus charge. And this dipole is making angle theta from the field. In this condition, you know very well that the torque will act on the dipole and the value of this torque will be tau is equal to Pe sin theta. Clear, students? Torque tau is equal to Pe sin theta. That you can see in my previous lecture. Yes, students? Tau is equal to Pe sin theta. This is dipole, this force plus QE, this force minus QE. The distance between two forces is this much and therefore torque is equal to any one force and perpendicular distance. That will give you tau is equal to Pe sin theta. See my previous lecture. Yes? Now, if this dipole is rotated through a small angle, what angle? D theta. This d theta against the torque. Torque is rotating it in clockwise direction and the dipole is rotated anti-clockwise direction by a small angle d theta. In this condition, work done will be what? dw is equal to tau d theta. Putting the value of tau, Pe sin theta d theta. And this is the small work. Yes? And if this dipole is rotated from angle theta 1 to angle theta 2 with the direction of field, then work done will be what? The total work done, W is equal to integration of dW from angle theta 1 to theta 2. The value of dW is P sin theta. P will be out of the integration. And this is integration theta 1 to theta 2 sin theta d theta and its value is minus cos theta. On putting the limits, this will be Pe minus cos theta 2 minus plus cos theta 1, that is W is equal to Pe cos theta 1 minus cos theta 2. W is equal to Pe cos theta 1 minus cos theta 2. Clear, students? And therefore, this work in rotating this dipole in electric field against the torque will be stored as electric potential energy. And therefore, the potential energy of the dipole in uniform electric energy, U is equal to Pe in bracket cos theta 1 minus cos theta 2. Clear? Students, this is the field. In this field, dipole is making angle theta. Now suppose that the dipole is placed like this. That is, the dipole is making angle 90 degree from the field. Dipole is making angle 90 degree from the field. Clear? In this condition, theta 1 will be what? 90 degree. Yes. And now this dipole is rotated by angle theta. That is theta 2 is equal to theta. Then what will be the potential energy of the dipole? When initially perpendicular to the field is rotated through angle theta, then U is equal to P cos theta 1 minus cos theta 2 is the formula for the potential energy. Now put the value of theta 1 as 90 and theta 2 as theta. So P is equal to cos 90 minus theta, and cos 90 is what? 0. And therefore you will get U is equal to minus PE cos theta. Clear? So therefore potential energy of dipole in uniform electric field placed perpendicular when rotated through angle theta, then energy will be U is equal to minus PE cos theta. Clear? And this you can write in the form U is equal to minus P dot E, vector P dot E. Thank you.